Okay, in question 3, we're asked to multiply some polynomials. In the first case, it's a binomial times a binomial. Not needed, but to organize your work, it might be nice to look at a generic area model. So for this one, I'm multiplying a binomial. That's two things. So I might, for example, write across the top a x and a -1. And then down along the side, I might write 2x and -3. So what happens is I now can find the product of all these four pieces. I can find the area of each of these rectangles. And then once I know the area of those rectangles, I would know the area of the entire shape. And again, remember multiplication, right? Multiplying x minus 1 times 2x plus 3 can be modeled by this generic area model. In the upper left-hand corner there, 2x times x is 2xx, or 2x squared. Below that, I've got a -3 times an x, which would be -3x. In the upper right, I've got a -1 times 2, which is -2x. And then below that, you can see I've got a -1 times a -3, and -1 times -3 is +3. So you can see these four pieces that are going to go together. Two of them are like terms, right? I can combine the x's. So I've got a -3x and a -2x. So my final answer would be that the product of these binomials, when I multiply them, is equal to 2x squared minus 5x and then plus 3. So this is what we're looking for. That is the product there written as the sum of the pieces. Simplified. Let's go to the next part. Next one, we have 2x plus 3, but that's getting squared. Common error is I still see people just calling that 4x squared plus 9. Please slow down. Remember, what it means to square something is to multiply that thing times itself. So I'm looking at the product of 2x plus 3 times 2x plus 3. If I take a look at our area model, we're looking at something along these lines. Across the top, I've got a 2x and I've got a 3, and then down on the side, I've got a 2x and I've got a 3. So they're identical, right? It is literally a square because I'm squaring these. I'm gonna get a perfect square. So the area that I get for each of the pieces, 2x times 2x, is 4x to the second power. 3 times 2x is 6x. And 2x times 3 is also 6x. And then finally, 3 times 3 is 9. You can see the pieces that go into this product. And when I simplify it, oops, that just went away. It is 4x squared plus 12x. What is that? That 12x is what I get when I add 6 times x plus another 6 times x. So I get a 12x. And then finally plus 9. So this is the product that I get when I square the binomial 2x plus 3. And then finally, the last one here, this is simplest form of the distributive property, right? I don't require an area model for this, and I don't think you do. I'm going to be multiplying this 2x by both the 3x and by the -5. So I get the product here is equal to 6x squared and then minus 10x. Pretty straightforward. All right, I'll just do two questions at the same time. Let's just go ahead and flow down to question, no, actually, let's stop there.